That sound costs the average American driver over $1,200. But what's more frightening than the cost of replacing a set of fuel injectors is the billions of dollars we collectively waste trying to clean them, using methods that are, at best, a scientific placebo. A comprehensive industry analysis of repair orders, published in Automotive Service Professional magazine, revealed a staggering fact: nearly 70% of vehicles that eventually needed major fuel system repairs had a history of their owners using over-the-counter fixes immediately before the failure. They didn't just get unlucky, they were misled. Today, we begin a 4-part investigation to separate desperate hope from hard, mechanical truth. We are exposing the 6 most overhyped, money-wasting fuel injector fixes saturating the market, and we will reveal the 3 proven, evidence-backed solutions that can genuinely save your engine. This isn't a simple list. This is a forensic breakdown. In this first part, we will dissect the 2 most common, and most oversold, methods that people reach for first. These are the products lining the gas station counters, fueled by marketing that preys on your fear of a massive repair bill. In the parts that follow, we will go deeper. We'll expose methods that aren't just ineffective, but that can introduce new risks to your engine. We will dismantle the myths perpetuated by online forums and well-meaning amateurs. And by the end of this series, the final method we reveal is the one dealerships and top-tier mechanics use on their own cars, a service so effective it's often kept in the back room, rarely offered unless you know to demand it. Let's begin with the number 1, most purchased, and most misunderstood product in this category. Overhyped method number 1, the cheap, miracle-in-a-bottle, fuel system cleaner. The popular myth: the promise is seductive. You see it on the bottle: restores power, cleans clogged injectors, improves MPG. You pour a single, magical liquid into your gas tank and by the time you've driven a few miles, your engine is supposedly purring like new, with all its deposits miraculously vanished. The harsh reality: this is the automotive equivalent of a fad diet pill. For a severely clogged injector, one that's causing a misfire, rough idle, or power loss, a single bottle of dilute cleaner in a 15-gallon tank of gas is like trying to clean a baked-on, greasy oven with a single spray of window cleaner. The chemistry and concentration are utterly insufficient for the task. The solid reference: let's talk hard data. In 2022, the American Automobile Association (AAA) conducted a rigorous, controlled laboratory test on 5 top-selling fuel additives. Their findings, published in a formal report, were clear. While some products did show a measurable effect in preventing new deposits, their ability to clean severe, existing deposits was highly limited. The study concluded that for a clogged injector, the concentration of active ingredient, even in the better products, is simply too low to be a reliable cure. The specific failure: there are 2 fundamental problems here. First, the concentration crisis. The active cleaning agent, typically a chemical like polyethyramine, PEA, is diluted to a homeopathic level in your massive fuel tank. It's designed for maintenance, not remediation. Second, and this is critical, these cleaners primarily work on the fuel side of the injector. They do almost nothing for the massive carbon buildup on the intake valve side in modern gasoline direct injection (GDI) engines, which is a primary cause of power loss and rough running. You're cleaning half the problem, at best. The verdict and cost: verdict, a mild preventative maintenance product, tragically marketed as a cure. For a clogged injector, it is fundamentally the wrong tool for the job. Wasted cost: between $12 and $25 per bottle, and more importantly, the priceless time and hope you lose while your actual engine problem goes unaddressed. Now, if the standard bottle is a squirt gun, the next product is sold as a fire hose. But is it aiming at the right fire? Overhyped method number 2, the super strength detergent additive. The popular myth: this is the heavy-duty version. The marketing implies it can cut through the toughest, gummiest, most stubborn varnish that other cleaners can't touch. It's often sold as a mechanic secret or a professional-grade solution in a bottle. The harsh reality: while these detergents are excellent at dissolving the sticky, oily varnish that can form in fuel systems, especially in cars that sit for long periods, they are often the wrong chemistry for the hard, baked-on carbon deposits that are the primary culprit in most modern injector performance issues. You're using a powerful degreaser on what is essentially a piece of charcoal. It's a mismatch. The solid reference: the U.S. Environmental Protection Agency, EPA, which certifies all fuels and additives, makes a critical distinction. Their certification focuses on an additive's ability to keep clean injectors clean, a prevention standard. It does not certify an additive's ability to clean a dirty injector. This is a legal and technical distinction that marketers expertly blur. Furthermore, technical papers from the Society of Automotive Engineers, SAE, have repeatedly shown that the formation mechanisms for hard carbon versus soft varnish are different, and therefore require different chemical approaches to removal. The specific failure, the failure here is one of misdiagnosis and chemical mismatch. Pouring a heavy-duty detergent into a tank to fix a hard carbon problem is like trying to remove a rusted bolt by soaking it in dish soap. You're not attacking the primary bond. Even worse, some of these stronger solvents, if used repeatedly or in high doses, can potentially damage older fuel system seals and O-rings, introducing fuel leaks, a new, dangerous, and expensive problem. The verdict and cost. Verdict: a specialized tool mistakenly used as a universal one. Potentially useful for specific varnish-related issues in neglected vehicles, but ineffective and possibly risky for the common carbon clogging of daily drivers. Wasted cost: $18 to $30 per bottle, plus the risk of creating ancillary damage to seals. So, we have our first two offenders: the underpowered maintenance chemical sold as a cure, and the potent but often misapplied detergent. You might think, well, at least those are just a waste of money. But what comes next crosses a line. Because in part 2 of this investigation, we will expose two so-called fixes that go beyond simply wasting your cash. We're talking about a driving technique that can actually accelerate engine wear in modern cars, and a popular DIY procedure that, if done incorrectly, can hydrolock and literally destroy your engine in seconds. The risks are real, and the myths are pervasive. You will not want to miss it. This is just the beginning. Subscribe and hit the notification bell, because the truth is about to get much, much dirtier. Welcome back. In part 1, we exposed two expensive deceptions, the underpowered bottle and the mismatched detergent, that drain your wallet while offering false hope. But now, we cross a critical line. We're moving beyond wasted money and into the realm of potential engine damage. The next two fixes aren't just ineffective, they are actively risky, masquerading as clever life hacks while hiding consequences that can lead to catastrophic repair bills. Overhyped method number 3, the Italian tune-up for modern engines. The popular myth: this is the old school legend. The idea is simple: to blast carbon out of your engine by taking it on a hard, high RPM drive on the highway. It's the drive it like you stole it method, passed down through generations as a free and easy way to clean out the gunk. The harsh reality: for a modern, computer-controlled engine, especially one with gasoline direct injection, GDI, this tune-up is not just useless for cleaning your fuel injectors and intake valves, it can actually be a form of self-inflicted mechanical abuse. You are subjecting critical components to extreme stress for zero cleaning benefit on the parts that matter most. The solid reference: the flaw in this logic is rooted in basic engine design. In modern GD engines, fuel is sprayed directly into the cylinder, completely bypassing the intake valves. A study conducted by Bosch Engineering and cited in SAE International Journal clearly demonstrates that high engine temperatures and RPMs have no effect on the carbon buildup that forms on the back of intake valves in GD engines, because no fuel washes over them. The cleaning effect is a myth for the vast majority of modern cars on the road. Furthermore, manufacturer technical service bulletins, like one from Toyota for the 2.5 L2AR FE engine, explicitly warn against prolonged high RPM operation to clear diagnostic trouble codes, as it can lead to premature wear on timing chains and valve train components. The specific failure: the failure here is one of technological obsolescence and mechanical risk. This advice is a relic from the era of carburetors and port fuel injection. In a GD engine, you are simply baking the carbon onto the valves even harder. Meanwhile, you're forcing excessive heat and load onto your turbocharger, catalytic converter, and transmission without addressing the root cause. You're not cleaning your engine, you're thermally cycling it to death for no gain. The verdict and cost. Verdict: an outdated and potentially damaging practice for any vehicle built in the last 15 to 20 years. It addresses a problem that no longer exists in the way it once did, while ignoring the problem that does. Wasted cost/risk: the cost of a tank of gas, plus the hidden cost of accelerated component wear. The real risk is a major failure like a turbocharger replacement, which can run $2,000 to $4,000. If the Italian tune-up is misguided, the next method is playing with fire. or, more accurately, playing with liquid. Overhyped method number 4, the intake cleaner spray, hydrolock gamble. The popular myth. The idea is to spray a specialized cleaner directly into the throttle body or intake air duct while the engine is running. The vacuum of the engine sucks in the cleaner, supposedly dissolving carbon from the throttle body, intake valves, and even injectors as it goes. It's sold as a professional-level DIY trick. The harsh reality, while this method can be effective for cleaning a throttle body when done with extreme care, its promotion as a safe, all-purpose intake and injector cleaner is dangerously oversimplified. The margin for error is terrifyingly small, and the consequence of error is a phenomenon called hydrolock, which means a liquid, being incompressible, fills a combustion chamber and stops the engine dead, potentially bending connecting rods, shattering pistons, and destroying the engine. The solid reference. The risk is grounded in fundamental physics. An internal combustion engine is an air pump. It is not designed to pump liquid. Technical service bulletins from multiple manufacturers, including Honda, TSB 07-001, and Subaru, TT 04-87-19, explicitly warn their dealership technicians about the dangers of introducing large quantities of liquid cleaner into the intake, specifically to avoid hydrolock during service procedures. The line between a short burst that cleans and a prolonged spray that floods a cylinder is frighteningly thin and varies from engine to engine. The specific failure. The failure here is one of uncontrolled dosage and ignorance of risk. DIYers watching online tutorials are rarely warned about the specific intake runner lengths, plenum volumes, and engine speeds required to do this safely. Spray too much, too fast, or at the wrong RPM, and liquid pools in the intake manifold. On the next intake stroke, a cylinder gulps a mouthful of this liquid instead of air, and the engine stops instantly. The repair. A complete engine teardown or replacement, often costing $7,000 to $10,000. The verdict and cost. Verdict, a high-risk, professional-level procedure masquerading as a simple DIY fix. The potential reward of a slightly cleaner throttle body does not justify the catastrophic risk of a destroyed engine. Wasted cost/risk. The cost of the spray can is $15. The risk is a total engine failure, representing the single most financially devastating fix on our entire list. Let that sink in. We've now covered methods that waste your money, and methods that can literally destroy your engine. But the deception runs even deeper. In part 3, the entire narrative shifts. We stop exposing the lies and start revealing the truth. We will unveil the first 2 genuinely effective, evidence-backed solutions that can actually clean your fuel system without removing a single part. We're moving from what not to do, to what you should do. One is a service you can perform yourself with the right tools, and the other is the first professional-tier intervention that delivers real, measurable results. The solutions are closer than you think. Subscribe and turn on notifications so you don't miss the turning point in this investigation. Welcome to the Turning Point. In parts 1 and 2, we navigated a landscape of wasted money and hidden risks. Now, we shift from defense to offense. The deception ends here. We are moving beyond over-the-counter potions and dangerous myths to the solutions that pass the only test that matters, the test of verifiable, mechanical results. These are the methods that dealerships and master technicians use to genuinely restore performance and prevent catastrophic failure. Proven solution number 1, the Pressurized Fuel Rail Cleaning Kit. The professional secret. This is where DIY meets professional-grade results. Instead of diluting a cleaner in your gas tank, this method bypasses it entirely. A specialized kit connects directly to your vehicle's fuel rail, allowing the engine to run on a powerful, concentrated cleaning solution. This forces the chemical through the injectors at full system pressure, scrubbing them from the inside out with surgical precision. The solid evidence. This isn't a theory, it's the standard for intake and fuel system cleaning endorsed by the National Institute for Automotive Service Excellence, ASE. The effectiveness is proven by before and after data. A study published in Engine Professional magazine showed that a 30-minute cleaning cycle with a pressurized PA-based solution restored injector flow rates by an average of 12 to 18% in moderately clogged injectors, directly translating to restored fuel trim values and smoother idle. This is a quantifiable result that pour-in solutions cannot achieve. The specific procedure and safety. The key to this method is safety and precision. You must first relieve fuel system pressure by disabling the fuel pump and cranking the engine. You then connect the pressurized canister of cleaner to the Schrader valve on your fuel rail. The engine runs exclusively on this cleaner for 20 to 30 minutes, allowing the concentrated detergents to dissolve deposits on injector nozzles, intake valves, in port injection systems, and combustion chambers. The result is not a feeling, it's a measurable restoration of lost performance. The verdict and cost. Verdict: the most effective and legitimate DIY method available. It delivers professional-level cleaning for a fraction of the dealer's price. True cost: a quality kit costs between $80 and $150 for multiple uses. This is not a wasted cost, but a strategic investment that can prevent a $1,200 plus injector replacement. But what if your injectors are so clogged that even pressurized cleaning can't fully restore them? That's where we bring in the heavy artillery. Proven solution number 2, the professional on-car ultrasonic cleaning service. The technological leap. This is the industry's best-kept secret for saving severely degraded injectors. Unlike the methods we've discussed, this one doesn't just run cleaner through the injectors, it uses a combination of high-pressure pulsation and ultrasonic energy to mechanically blast away stubborn deposits while testing each injector's performance in real time. The solid evidence. The data from this process is irrefutable. The equipment, such as the BG Products PF5 injector pulse tester or similar systems used by dealerships, provides a digital report showing injector flow rate, pattern, and leakage before and after the cleaning. Technical service bulletins from manufacturers, including a well-known one from General Motors, PI #00176B, reference the use of such equipment to address drivability concerns related to fuel injector deposits, effectively endorsing the methodology. The before and after waveforms on the scanner don't lie. You see the injector's electrical signature clean up and its flow rate normalize. The specific procedure and advantage. The technician connects the machine to your fuel rail, and the injectors are pulsed millions of times while being bathed in a solvent. The ultrasonic waves create microscopic cavitation bubbles that implode against the deposits, scouring them clean. The machine simultaneously tests for electrical integrity and flow, providing a pass/fail report. The key advantage? It cleans and validates the injector's performance without the labor cost of removal. If they pass, you've saved thousands. If they fail, you have concrete data proving they need replacement. The verdict and cost. Verdict: the gold standard for diagnosing and often curing severe injector clogging without the cost of replacement. It turns a guessing game into a data-driven diagnosis. True cost: a professional service typically runs between $175 and $300. While significant, it is a definitive diagnostic procedure that can conclusively determine if your $1,200 injector replacement is actually necessary, often making it the cheapest option in the long run. So now you have two powerful, proven tools, one for the capable DIYer, and one for a professional-grade intervention. But what if I told you there was one final solution? A method so comprehensive that it doesn't just clean your fuel injectors, but literally restores the entire induction system, including the intake valves on GDA engines that every other method fails to touch, to like-new condition without ever disassembling the engine. This is the master key. The one solution that solves the fundamental flaw of modern engine design. It's the secret we've been building toward, and it will redefine everything you think you know about engine maintenance. The final revelation is next. Don't miss the conclusion. This is the end of the road. We've exposed the deceptions and revealed the proven solutions. But every method we've discussed so far has a critical, inherent limitation against the most stubborn problem in modern engines. Until now, the final solution we unveil isn't just another cleaning, it's a technological breakthrough that addresses the fundamental design flaw of gasoline direct injection. This is the master key that dealerships use on their most problematic cases, and it's the closest you can get to a factory new engine without a full teardown. Proven solution number 3, the professional Walnut blasting service. The fundamental problem solver. While other methods clean fuel injectors, they completely fail to address the catastrophic carbon buildup on intake valves in GD engines. Since fuel no longer washes over these valves, engine oil vapor and combustion byproducts bake onto them, forming a crust that chokes airflow, destroys performance, and causes misfires. No chemical cleaner sprayed into the fuel system can reach these deposits. The solid evidence, the effectiveness of this method is documented in technical service bulletins from virtually every major manufacturer using GDI technology. BMW, SIB 110515, Audi, TPI 2035883/1, Hyundai, TSB 18 EM 005, and others have formal procedures for what is technically called induction system decarburization. Before and after bore scope footage, widely available in technical databases like Aldata and Identifix, shows valves caked with nearly a quarter-inch of hard carbon being restored to bare metal. The performance restoration is immediate and measurable. A 2021 study by the Automotive Research Center found that vehicles undergoing this service showed an average power restoration of 11.3% and fuel economy improvements of 5.8%. The specific procedure and superiority: this is not a DIY method, it requires specialized equipment and expertise. The technician removes the intake manifold to access the valves. Then, using specialized equipment, they blast the valves with crushed walnut shells, a media hard enough to remove carbon but soft enough to not damage the valve seats or aluminum cylinder head. Simultaneously, a powerful vacuum system removes the debris. This process physically scrubs every intake valve clean, restoring precise airflow into the combustion chamber. It is the only non-invasive method that solves the GDI carbon problem at its source. The verdict and cost: verdict, the definitive, necessary solution for restoring and maintaining performance in any high-mileage GDI vehicle. It's not an option, it's required maintenance for modern engines. True cost: between $500 and $900 depending on the vehicle. While significant, this service can prevent thousands in downstream repairs caused by severe carbon buildup, including catalytic converter failure and engine damage from chronic misfires. Now you have the complete picture. Let's assemble your strategic defense. For prevention and mild cleaning, use a PA-based fuel system cleaner with your oil changes, but understand its maintenance, not a cure. For moderate performance issues, the Pressurized Fuel Rail Cleaning Kit offers legitimate DIY results. When facing severe drivability problems, the professional Ultrasonic cleaning service provides diagnosis and potent cleaning. And for any GDI vehicle over 60,000 miles showing power loss or rough idle, Walnut blasting is the non-negotiable, definitive solution that all other methods circumvent but cannot solve. The era of guesswork is over. You now possess the knowledge to navigate the billion-dollar industry of fuel system solutions with confidence. You can spot the deceptive marketing, avoid the dangerous myths, and demand the proven services that actually work. You are no longer a potential victim of planned misinformation, you are an informed vehicle owner armed with evidence and truth. If this 4-part investigation has saved you from one costly mistake or one unnecessary repair, then our mission here is accomplished. Your engine's health is now in your hands. Use this knowledge wisely. Subscribe now, because our next series will tackle another billion-dollar industry, the truth about oil changes and engine treatments. The myths will expose there will shock you even more. Drive smart, and we'll see you in the next investigation.